In this video, we're going to we're going to find the indefinite integral of a inverse trigonometric functions. So find the indefinite integral of the inverse trigonometric function. There are plenty of formulas that we can use so far to solve the inverse trigonometric functions. For this one, if you look in the book, you would see this is really related to arc secant, right? That would be related to inverse secant. For example, you know one of the formula for the inverse trigonometric functions for integrations is you can have, if you have something that looks like du over u square roots of u square minus a square. If you have something in this format, the answer would be 1 over a arc secant u over a plus c. Because it's indefinite integral, we need to add the constant c, and they already asked us to use c for the constant of integration. But looking at this one, if we set u equal x squared, for example, we don't have x squared at outside. So what we're gonna do, perform some operations to show that if we rewrite, for example, this one as 1 over x square roots of x squared power 2 minus 2 square, let's say 2 square. All right. You know what? I'm going to try to write clearer so you can see everything. All right. Now, let's do, we have 1 over x times x squared power 2 minus 2 square. So we can consider u as x squared and a as 2. But unfortunately, outside of our radical, you will realize we only have x, so that x cannot represent u. What we're gonna do is really perform some operations in these equations. So we're going to multiply the top one and the bottom one by 2x. So we go, we have 2x, okay, dx. Of course, there was supposed to have a dx here. 2x dx over, we're gonna multiply 2x times x we had, x squared power 2, because power 4 is x squared power 2. So when power over power, we multiply the exponent, we can have our x power 4 back, and we have 2 power 2. And remember, this is the square root of it. Now you see, by multiply and divide by 2x, so it's like having 1. So 2x over 2x is 1. You don't really change anything. So I'm going to bring the 1/2 outside, because for us, or if you don't see where it's come from, I'm gonna leave it for now and show you I still have 2x dx on the top, and at the bottom I'm gonna have 2x squared square roots of x squared power 2 minus 2 square. Okay, now you see I can bring that constant outside. So the 1/2, I'm gonna bring the 1/2 out and keep 2x dx on the top. The reason why I keep 2x dx is because I know already when I set u equal x, is gonna give me 2x dx for the derivative. So we have x squared square roots of x squared power 2 minus 2 square. Now we can let u equal x squared. So what would be du? Yes, du would be 2x dx. You see, 2x dx in the numerator represent du. Then we can let a equal 2. Now, because we have these two informations, we're gonna continue right here by putting an equal sign. We still have our 1/2 outside. 2x dx, we call it du. Now, we have x squared is u, square roots of x squared power 2, so it's u power 2 minus 2 square is like a square. All right. Now we end up bringing our, antiderivative or our integral in this format. You see, this one is the same thing like this one. All right. If you see this, I can erase and continue. Now I know this answer would be this 1/2. I'm gonna keep it outside because this was not part of it. So we would simply use that formula is 1 over a arc secant u over a plus the c constant. Now I know what is a and I know what is u. I can simply substitute. I have 1/2 1 over 2 arc secant u is x squared over 2 plus c. I can leave it like this, or I can multiply that by the 1/2. So I end up having 1/4 of arc secant x squared over 2 plus c. Always add the plus c when you try to find the indefinite integral. But if it was definite integral, it should be different. You wouldn't have the plus c. So that would be your final answer. So remember, when we said arc secant, in some books you might see arc secant, or you can see secant power -1 is the same thing. So it tells you is the inverse of secant. So hope this video help you to find the indefinite integral of inverse trigonometric function. This is one of the examples, but they could give you one that would involve arc sinus or arc tangent, but use this one to do more. Hopefully you enjoy it. Don't forget to subscribe for more videos. Have a good day.